Thank you all for joining. Again, this is the day 2 for the summit. And my name is Ranjan Priyadarshi. I'm a product manager for database in memory. And again, I'll share the agenda for today. And again, we are very excited to have you here. We had a very exciting day 1, great turnouts and lots of interaction, question, discussions. If you're able to make it, thank you for attending and interacting with us. And please send us any feedback on the summit to me, okay? And I'm hoping we will have a very exciting day 2 as well. Again, please keep the questions going and discussions going. So I'll talk about a little bit about the intro and kind of switch gears and talk about, so yesterday we talked a lot about the motivation of database in memory, okay? And today we will talk about the real life applications of database in memory. So basically start with who needs database in memory. And if you're working in the business which requires critical and timely reports and analytics, you need database in memory. If you have business dashboards, business KPIs, you need database in memory. If your lines of business, they need critical reports to meet their SLAs and all, you need database in memory. And if you're copying data to another system and adding complexity, yeah, you need some advanced technology here and so forth, right? So the list goes on. And if you're one of those guy on the left, or if your business users are screaming, you definitely need to think about it. This is a typical customer scenario, okay? And I took it directly from a customer who reported their problem, okay? There are a lot of business reports and filters which keeps on changing. And you can't create indexes on it because the filters and the predicates, they keep on changing, and optimizing those kind of workloads are pretty complex, okay? And these slow reports are huge productivity drain throughout the organization. And the kind of pain flows throughout the organization, starts with the business user, down to the developer, to the DBAs, to the storage and networking guys, right? So basically the whole organization is involved. And it happens at the end of every month or every quarterly cycle. And that's why this is a vicious cycle that goes on. So what is the impact of delayed analytics to the organization? It leads to kind of poor services, customer dissatisfaction. You are slow to react to market needs, slower to competition, slower in innovation, and the list goes on, right? So there is a huge cost of delayed analytics. Here is another customer scenario, okay? Again, this is directly taken from a customer who reported a problem, okay? Whereby the reports, the newly created reports, they don't meet those SLAs, or the reports are frequently missing those performance SLAs, okay? And it could be happening because of many things, because of hourly loads, because of other things happening on the system, or poorly created queries and so forth, right? So this is another kind of customer scenario. So those were the kind of tactical things that also need attention. Now, taking this to a kind of at the enterprise level, there the need for the real-time analytics or digital transformation is happening across the industries, whether it's insurance, retailers, manufacturing, finance, telecom, everywhere it's happening. The retailers are doing location-based analytics, manufacturing is doing quality analytics, finance is doing the risk fraud analytics and so forth, right? So the need for real-time and digital transformation is happening now, and everybody needs a fast and real-time analytics. So what are the key benefits of database in memory? And we covered this yesterday as well. And so there are kind of 2 categories of benefits. One is the speed up of the data warehouses, speed up of transaction analytics, business intelligence, dashboards, critical reports, faster ad hoc analytics, and so forth, right? And then you also have the advantage that you get lower data footprint due to high compression, you get lower TCO, or total cost of ownership, and you also minimize data duplication and reducing cost and complexity. So these are the benefits. I mean, take the analogy. I take the analogy of kind of doctors prescribing us cholesterol, right? And you want the good cholesterol to go up, and the bad cholesterol to go down, right? So this is similar. So there are a lot of things happening about making the data warehouses faster, and then you also want to lower the cost and complexity. So these were the kind of the technical benefits, and now talk about the business benefit, right? And this is what we touched upon earlier, okay? With the faster analytics, you get the faster time to value, you can innovate faster, you can you have the simplicity, you can enable self-service, you can lower the total cost of ownership and all. So these are the kind of business benefits. We touched upon this yesterday. This is what are the different customers they are seeing the business benefits out of database in memory. A lot of customers are seeing 100x to is a kind of a lower number as well, but 100x performance improvement, 30x performance improvements, 12x performance improvement, and so forth, right? So the mileage may vary, okay? However, there are definitely a lot of, like I said, technical and business benefits of the database in memory. And like I said yesterday, we would like to see your names and success stories here on this map at the next summit. So what are customers using database in memory for? Again, we look through all the customer and talk to many customers, and this is what we get to, okay? The usefulness of database in memory is across industries. I get questions many times, hey, can I use it in retail? Can I use it in finance? Can I use it in airline, banking, and so forth, right? So the usefulness of database in memory is agnostic, and it can be useful across the industries, okay? And many of these critical customer applications, and this is where it shines a lot, okay? Providing services, running operations, maintenance services, and you will hear about all these things from our customer speakers as well. And also, it's very beneficial when you scale the business, okay? If you are moving from 10 users to thousands of users to thousands of reports, this is where database in memory gonna shine, okay? And that is where you need the critical, you need to meet those critical SLAs and all. And so if anywhere you need to accelerate the business decisions, that's where you need database in memory. Again, this slide I showed yesterday, it's not that we are getting started. Many of the best and the biggest in the business, they are using database in memory. The largest electronic manufacturer, the largest automaker, the largest retailer, and the list goes on, right? So it's a huge list of the best and the biggest in the business. And there are a lot of small and medium size as well who are using database in memory. And as everybody is working on digitalization and modernization, the fast and real-time analytics will be necessity and key enabler, okay? And basically everybody will need the fast and real-time analytics. And that's where the database in memory is, it will also become a necessity for everyone. So now, again, change gears and talk about, hey, the agenda today. So yesterday we had 2 keynotes from Tirthankar and Rich. Today we will have keynote from Ahmed, and who will talk about the applications of database in memory. And then we will have a lot of these customer success stories. In the morning, we will hear from Benoit, from Steph, as well as Mr. Penske from Lufthansa. And then in the evening, evening hour time means PST time, you will hear success stories from Hisense. This is the agenda. I believe all of you should have agenda. I sent again last night, so you should have the agenda. Again, we are talking about session 3 and session 4 on the bottom. Some housekeeping items before we start. Please do ask questions. We love questions. Please don't ask in the chat window, ask in the Q&A. And also, please subscribe to the LinkedIn channel. This is where we want to collaborate with you, work on your solutions and so forth. The sessions are being recorded, and also use social media to talk about this event. Use the hashtag DB in memory. Okay, with that, let me stop sharing and we'll invite the first keynote speaker to the stage. Okay, so our first speaker is Ahmed Alomari. Ahmed, you can start setting it up, please.
Sure.
Okay, so I will just introduce yours. Yeah, so Ahmed Alomari is an entrepreneur, author, and Oracle ace, and well known in the industry for his systems expertise. And he has provided professional advice to Fortune 500 companies as well as small and medium-sized business in a global capacity. His title is Utilizing Oracle in-memory to Improve Application Performance. In this session, he will present an overview of Oracle in-memory features as well as an example and use cases to improve application performance. As data sets continue to increase significantly, the need for in-memory processing is essential in order to scale, ensure optimal application performance, and provide real-time data insights. Ahmed, stage is all yours.
Thanks, Ranjan. Good morning, everyone. My name is Ahmed Alomari. I'm going to talk about utilizing the Oracle in-memory feature within applications. So as far as the agenda for the session, I'm going to talk about what is in-memory, just to kind of level set, and the business case for using in-memory, why is it important, and also cover some application use cases where we have used it successfully and seen significant benefits. And then hopefully time permitting, we'll allow for some Q&A at the end.
Yeah, Ahmad, sorry to interrupt, but there's some background noise there.
Oh, okay. Is that better?
I think it's probably because of your movement, maybe. So yeah.
Oh, okay. Okay, so we'll talk about what is in memory. So the concept of in memory obviously is nothing new to application space specifically. The idea obviously is that the data itself is stored in the system memory in order to improve performance in avoiding, for example, executing SQL statements to load the data or analyze the data, and obviously avoiding the latency of having to transform the data into a format that the application requires it or that the users require, for example. So the other idea is that basically when the data is loaded in memory, you can essentially use sort of a divide and conquer approach to access that data, transform it, and avoid, for example, any physical I/O because the data itself is in system memory. And when we talk about data with respect to applications, of course, there's generally two classes of data that we refer to. One is our transactional data. For example, typically we'll have like dashboards, for example, order dashboard to keep track of the orders, which ones are pending, which ones are about to ship, which ones are still pending shipment. And then maybe on the reporting side, for example, financial dashboards, which would give you a picture of revenue, outstanding collections, things like that. And then we have what we typically call the reference data, such as like the master list, where we store the item definitions, for example, customer definitions, locations, address information, etc. That's where we typically get referred to as either lookup or reference data. And the idea with in-memory processing, of course, is really the expectation is that it should yield orders of magnitude improvement. It's not something that you should get 10% or 15% or 20%. And we have really seen that before by switching from conventional to just executing SQL to access the data, switching it to using some kind of in-memory processing. You do see that type of orders of magnitude, 10x, 50x, 100x, that type of improvement. So it's not something that really translates into a marginal improvement. It's really designed to allow you to have orders of magnitude improvement so that the application can scale. You can support more users. The data sets themselves can scale. You can support more business units, etc.
Ahmed, as you're speaking, we can hear a rattle when you speak. It's possible the microphone may be vibrating for some reason if you have a headset on. I'm just echoing what some of the people are saying.
Okay. Let me see.
If you have a headset, sometimes the headset, if it moves while you're speaking, you can get some sort of rattle feedback.
Okay, let me see if this is any better. Okay, is that better?
Yeah, it's still there, but it's not as pronounced as before. So it's I think it's let's go with it and see how.
Okay. Okay. Apologize about it. So I'll try not to move.
Yeah.
The other thing is that, for example, with respect to the caching memory and data. So in applications, for example, prior to this great feature of in-memory processing, we've had to really go to great lengths to essentially try to cache the data, wherever possible, either in the PL SQL server side, sometimes in the client PL SQL, sometimes in the Java code, etc. But to give you a simple example here, which during tax processing, when an invoice is created or even an order is booked, for example, and then starts the invoice creation, typically there's some tax lookup information that needs to be done, and that's typically done by the set of books. And so typically there would be a API call in the tax engine, and that would execute the SQL statement of this form to hit AR system parameters all, which stores a lot of the setup data for that ledger or operating unit. And typically that SQL would take, for example, for 500,000 executions, about 33 seconds. Very straightforward, simple SQL using a key access kind of. But for example, when the tax API was changed to cache this data by using just a getter and storing it in a PL SQL collection, that same get now takes 40 milliseconds, right? So that's a speed up of over 800x. That's really the type of improvement that applications expect when they move to some form of in-memory processing, whether it's done at the application layer or whether it's using APIs or cache frameworks or something like that. So again, just to kind of set the stage that this use of database in memory really provides that type of orders of magnitude improvement. So real quick, I don't want to, obviously, I'm sure the in-memory piece was covered in detail in yesterday's sessions, but just for those of you who may be new to the feature or maybe familiar with the applications, but not too familiar with the database feature itself. Essentially, the way the database in-memory works is there's a in-memory column store, which stores it in a compressed columnar format. It's part of the SGA. So there's a parameter called in-memory size to control how much you give it, whether it's, for example, 10 gig, 20 gig, or however large, you're able to allocate that. And then obviously the, in-memory area can grow as well, as along with the SGA, if you're using, for example, the automatic memory management to allow the SGA to grow and shrink based on the load. So the way it works, and of course, one of the great features of this is, again, to give the example on the application side, whenever we use some sort of in-memory technology or caching at the app layer, it requires a lot of code changes, obviously, to be done. And there's a lot of things that have to be handled in terms of cache invalidation, when is the cache updated, et cetera. So the beauty really of this feature is you turn it on really at the database level, and you specify which tables or objects get placed in the memory store, and then you just continue to execute your normal SQL statements, and the data blocks typically would be stored in the buffer cache in typically what's tuple format or row format, and then in the column store you have this new in-memory format, which is a columnar format, to allow for like vector processing, or essentially spinning through a large amount of data in a quick fashion, as opposed to the traditional of having to iterate through each of the tuples or each of the rows that you might be used to for just executing SQL. So again, that's one of the big benefits, is that it's sort of transparent to the application, because the objects themselves are just placed in the in-memory store, and the database essentially takes care of that transformation versus you having to do that same type of thing through application code. So why in memory? Especially as a business case, obviously, if, for those of you who are in charge of convincing your management to purchase features, obviously there, you have to do that justification in terms of, why that additional spend. So today, as you can see, the data growth is phenomenal, especially in the application space. We're not just storing, transactional data anymore in terms of, quotes or orders or journal entries or invoices, for example. There's a tremendous amount of unstructured data that's also being stored, that's also being co-loaded with the application as well. There's streams of data, meter data. So the amount of data growth has been phenomenal. And if you look at the progression, over time, especially in the e-business suite space, people started probably in the 90s, I would say, with several hundred gigabyte databases, which was large at that time, not very large today. And then, in the mid 2000s, kind of, breached the terabyte space. And now we have e-business suite databases that are almost 150 terabytes in size. And the data keeps growing, and those are just the e-business suite databases. The non-e-business suite databases that store meter data, et cetera, those are even growing into the petabyte space just due to the nature of the data set. So the amount of data that the enterprises are being asked to store and be able to process is significant. And along with that, the application responsive requirements haven't changed, right? We still need to provide UIs and transactional interfaces. Those UIs and transactional interfaces still need to perform efficiently. They still need to have reasonable performance. You can't have UIs, for example, running for minutes because typically they'll time out, and the users obviously will be very frustrated, and more importantly, they won't get the data that they need in order to do their task. And also, it's important that the business throughput itself depends on the query performance. For example, your order booking throughput, your shipping throughput, how fast you can send the containers to the conveyors, for example, so the trucks can come and pick up the goods. All of that depends on your query performance. So if your query performance is slow, then obviously you'll limit your business throughput. So it's very critical that as the data sets scale, application performance itself needs to scale. And the other big thing is that most of you who use applications these days, the usage model has transformed significantly. Previously, e-business suite users would spend most of their time on reviewing transactional data, looking at orders that were entered or orders that are still pending, or reconciling financial transactions and things like that. That's now has become a small portion of their daily activities. Now the bigger portion is the data insight, because with data insight, that allows them to become more productive. It also allows them to, for example, open up other business opportunities or other markets, for example. So for example, which products should they be ordering? What should be their pricing model? What if they change their pricing model? What would that do to their revenue stream? What will that do to the orders, demand, things like that? So a lot of those data insights are now key, and database in memory is making that feasible. Previously, that was not feasible really prior to in memory. The solutions that a lot of customers had to do was implement expensive third-party BI solutions and basically extract the data out of EBS, put it in some kind of reporting instance, create a ton of summary and materialized view reporting tables, and then build those materialized views and reporting objects kind of static based on the reporting requirement. And so it didn't really give a dynamic nature. And obviously there's a lot of refresh issues associated with that, and a lot of maintenance that had to be done. Now with the database in memory and the concept of converged database, they're really a lot able to do that, and not only deliver fantastic performance, but more importantly, keep the data in the database where it belongs, rather than having to extract it just for the purpose of being able to have decent reporting performance. And the other thing is, of course, data analytics. That's a key thing. Again, along with the providing data insight, people are running AI and machine learning models against the data to look at, for example, forecast models, streamlining their supply chain and things like that. So the whole processing model, for typically transactional applications has really changed due to this AI and machine learning and data insight. And the other thing that is really has been introduced recently within package applications is the ingestion of large streams of data. So you have metering data, social media streams, all of that really didn't exist before, or was not didn't need to be stored inline type of thing. So that's another factor that also is very useful with respect to in-memory processing, to be able to process that data and also make sense out of that data while providing responsive performance. So according to IDC, they're forecasting that the unstructured data will actually outsize the transactional data that we typically deal with on the packaged applications. And you can typically see that, for those of you who are dealing with those types of data, IoTs, obviously all the sensor devices, meter, all the data feeds that are coming in, definitely those data sets will outweigh the journals and the sales orders and the quotes that you have. And as I said before, really the ability to be able to slice that data, search through that data, and get valuable data insight out of it is no longer a nice to have. Before it was a nice to have and people had to build, extricate BI solutions. Now that's really inherent in the application itself. The business users need to be able to search that data using the same set of UIs and be able to produce data insight and give them recommendations on things that can be done to improve their business model. So again, from the same IDC study, you can see that the data growth is just really becoming phenomenal. This is obviously in zettabytes, which is, I believe, 1 billion terabytes. And so, today, for example, we see e-business suite databases above 150 terabytes. 5 years ago, that would have been unheard of. And so the data growth has really been significant. And even the non-packaged, the non-ERP databases are growing even faster and larger. Another interesting growth pattern as well is that the real-time data, which again comes into the, in line with what we discussed earlier about real-time feeds, all the, for example, metering data, the IoT device data, for example, and also the need for a business insight on real time, right? Nobody wants to know their order forecast that's already a month or a week old, as would be the case when you typically build out some kind of BI or data warehouse or data lake. They really want to know real-time information and get some insight into the forecast. So that real-time data, again, that's really in line with utilizing database in memory to be able to provide that type of analysis with responsive performance. Another thing that I'm sure that most of you, either system administrators and database administrators who are on the session, you have seen this pattern that storage frames have been upgraded, and pretty much if you're not really on SSD or on an all-flash storage appliance, your company is probably in the process of doing that as we speak. So you can definitely see the adoption pattern going across, and a lot of that has been driven by the phenomenal growth of data and also the increase in performance requirements that is required. So previously, when there was mostly HDD or physical spindles to store the storage, and it was typically a tiered storage model, we would experience anywhere from maybe 7 milliseconds to like 10 milliseconds of IO service times, and under load it would probably go up to maybe 15 or 20 milliseconds. Now with the all flash appliances or SSDs, we typically see 0.7 milliseconds as an average, with maybe spikes of 1 to 2 milliseconds. So almost a 10x improvement in IO service times. So another reason again why in-memory is a really fantastic feature and is key to the success of the application is because again, previously without this feature, what had to be done is you had to pretty much build out some type of reporting database, whether it was a data warehouse, full-fledged, whether it was a data lake, a subset of the data, whatever the case was, you essentially kind of had to build that out, put together some extracts, extract that data, whether you create summary tables, roll-ups, materialized views, all of those challenges. So to start with, you always had that data staleness, which the business users never liked, right? They always want real-time data. And that was a challenge prior to having the ability to do something in memory. Data itself is being replicated across all the application nodes. You don't have all the bells and whistles with respect to data security, which is important these days with all the cyber attacks. And you have, of course, all the integration challenges in terms of the web services and the data feeds that may not be able to utilize those summary tables, for example, from the reporting instance. And the other important thing is you essentially had to do a lot of upfront design work to make sure that your data lake or data warehouse matches the types of queries that the business users would be executing. And that's very difficult to do because that essentially means you don't really have any ad hoc support. Anytime the business community wants a new report or a new view by, so to speak, or even a new roll-up, that would have to be an IT project to go and build that out again. Whereas with in-memory, you place the object itself in the in-memory store, and depending on the filters and things, the where clause can change, the group bys can change, the in-memory feature itself, and along with the optimizer, take care of that automatically for you. So in quick, basically one of the key components of in-memory processing and why it's able to improve performance is due to the usage of Simbi instructions. So Simbi actually has been around for a while. It just hasn't really had commercial application adoption. It was used for like, vector and graphic processing and even in gaming earlier, but now it has really been, uptaken to have commercial use. And basically the idea is that instead of having, a single instruction on a single data set, for example, you can have a single instruction operate on multiple data cells or multiple data elements. And so that allows you to essentially process a large set of streams of data, in a single set of instructions, as opposed to, one by one or iterating through or looping through type of thing. So some key features I think that are extremely useful for the applications, and then we'll get into some of the use cases, is in 21C, the in-memory automatic. I think that's really a fantastic feature because again, that'll allow all the segments to be considered for the in-memory store, or at least all the application-related segments. There's some restrictions in terms of like for system objects and things like that. But the ability that the database will essentially take care of worrying about, since obviously the database already knows what are the hot segments, it knows what are the cold segments, it knows what SQLs are being executed. So obviously it can make a better decision of which objects to place in the in-memory store versus having to do that upfront type of thing or a manual. And the other thing, as I mentioned, with unstructured data, for those of you dealing in, even web services or just unstructured data in general, the ability to, scan through JSON documents is also very useful. And you can use even the native JSON SQL operations as well. There's also a new in-memory hybrid scan in 21C, where essentially, for example, previously, if you had only a subset of the columns in the in-memory store, then and you referenced some columns that were not in the in-memory store, then the SQL would be, the rows would be referenced from the buffer cache entirely. Now with this hybrid, it can reference some from the buffer cache and some from the in-memory store, whichever columns are there. And that's a great feature as well. External tables, we also use that quite a bit. That's really useful if you're dealing with non-Oracle sources, such as, for example, if you have even like a Kafka stream, or sometimes if you have a Hadoop data source, that can also leverage the in-memory store as well. So again, some benefits of using in-memory, again, is, you get to leverage a native database security. So within apps, for example, we have a lot of data security that's built in terms of, securing the data by responsibility, securing the data by operating unit, by ledgers, et cetera. And so you don't really have to deal with all that or reinvent that by building out your own, reporting instance or data lake or something like that. It also allows you to really, achieve your performance requirements, especially for a lot of the ad hoc searches that the end users will do, and also provide, again, data insight, which is really key these days. And the other ability is, it's scalable, especially if you're, using RAC. You can basically continue to add nodes, like in the solutions that we typically have. Since we tend to deal with a lot of the larger enterprise sites, they typically almost always have RAC, and we're able to essentially, add nodes to the cluster in order to scale this out. And sometimes we even set up, a few of the nodes to have application affinity using RAC services, so that those types of queries, can be pinned to a few set of the nodes. Okay, application use cases. So within order management, there's obviously a number of areas that for which database in memory is useful. And I've just noted some of them that we've used. So with pick release, so if you think about pick release obviously is a critical job, and it's the job that's responsible for essentially finding out which order lines are candidates for shipment, so that you can basically create the label, get them picked and packed, put them in boxes and get them on the truck. That's essentially what the pick release process is. So it's a very critical process to in order to ship, and obviously in order to recognize the revenue for those shipments. And typically what pick release does is it has kind of this access path dilemma in that it needs, when it runs, it doesn't really have a good selective search criteria in terms of index filter. The number of records it returns is very selective, but the filters that pick release uses, a combination of like pick rules and all the open order lines, et cetera, and which warehouse it's coming from, things like that. Those are not really selective filters or naturally indexable. And so what you typically really have to do is scan through all the open order lines in the system. And for a large shop, that can be definitely millions of order lines. And pick release would be something that's running in the background all the time. And so that scan would be very, inefficient. And sometimes you'd have to create, a lot of secondary indexes just to help, facilitate that. So another, great example. The workflow background engine, of course, is another good example where, again, all the deferred activities, such as scheduling is another good use case. Interface trip stop has the same kind of dilemma that pick release does. So what pick release does is it has to find all the order lines that are pickable. Interface trip stop has to find all the lines that are shippable. So same type of, scenario, and cannot really leverage any specific, selective indexes. Order searches as well. One of the dilemmas with the, order organizer or even the sales order form itself is if you search by order number or by customer, you typically get reasonable performance. But a lot of users don't necessarily do that. They search by order date. They search by orders that are assigned to them. They search by orders that are in a certain state, maybe, for example, booked or waiting for schedule, or maybe orders that are on hold, things like that. So those search scenarios often become a challenge, and that you end up having to create pretty much a good probably 10, 15 indexes on the order headers and order lines in order to just facilitate reasonable performance. Credit summary refresh, that's also another area where what it's used for is essentially when an order is booked, it'll basically do a credit exposure check to make sure that the customer order amount doesn't exceed either their limit, or make sure that the customer can pay if the order prior to the order being shipped. So usually there will be some kind of credit check, and it might go on hold based on that. And there's a credit summary table that's maintained. So by putting the underlying objects in the memory store, the credit refresh, the program itself, it usually takes 10, 15 minutes on a tuned environment every time it runs. And of course, the business wants that to run all the time in order to make sure it's not stale. So as an example here, typically you would put the order lines and order headers table in the memory store. Just highlighting here order lines as an example itself. So here, for example, in our environment, the order line table was about 35 gigabyte in size. And the in-memory size, came down to about 4 gig. That's without, compression as well. So if we used even, higher level compression, that would be less. But you can see definitely that's almost like an 8x, improvement in terms of the, segment size. And even the alter table itself, at least in 19C, that command itself took under 10 seconds. So it didn't really take long at all. Here's an example of this is actually a pick release query. So typically it'll hit the shipment tables and order lines table, and then it'll scan through all the order lines. The query obviously is too big to fit on one slide, so I'm just going to highlight the relevant portion that you would have seen. So in the execution plan, you'll typically see that row source in memory. So it'll say table access in memory, full, and then the in this case the order lines table. And then you can see the estimated time of 2 seconds, which is the optimizer estimate. That's actually pretty close to what it actually took. So in terms of the times here, you can see, for example, if you do an open order search, meaning you go into the order organizer or sales order form and you search for all the open orders in the system, that used to take us about 5 minutes, and compared to 5 seconds when the objects were placed in the in-memory store. So huge improvement. Even the pick release query itself, again, it used to take close to about 2 minutes, a little under. Now it's taking 3 seconds. Interface trip stop used to take 78 seconds, now down to 4 seconds. Other areas, the credit summary refresh, as I mentioned, that program runs pretty much in the background all the time. Usually it takes anywhere from 10 to 15 minutes typically. And by putting those objects in the in-memory store, it came down to 37 seconds, which is a huge win because, again, the biggest benefit here is the staleness factor. Right, so orders that were placed, in the last 5 minutes, those would not show up, and that could impact the credit exposure. Now the credit exposure is very limited, so which is good for the business because you don't want to overcommit. And there's also another program called Order History, which basically collects all the order history and puts it in a summary table. That also came down from about 10 minutes to 23 seconds. So massive improvement, again, in line with the messaging of orders of magnitude improvement. On the value chain planning or VCP, so a number of areas that have improved that we've seen. So one is collections. So collections is the process where you essentially, when you set up your planning configuration, you essentially specify what your source ERP instance is. And it runs a program called collections to go and basically collect all the data, like collect all the demand data, your supply data, your inventory, your suppliers, your purchase orders, et cetera. So collects all that source data and then stores it in your planning tables, and then basically runs the plan against that to come up with recommendations on your supply chain planning. So that collections process is really pulling a tremendous amount of data. Typically that's run in complete refresh mode. So that itself improves considerably, because the queries, instead of taking tens of minutes, now take seconds. So a huge improvement there. And the benefit there, of course, is that you can run collections more often, which means you can run the plan more often, instead of typically these days, most companies can only run the plan once a day at most. Planning data pull is also the piece that pulls additional data from the EBS side, from the snapshots, and then populates the local tables. And then also the in-memory planner, which is the piece that essentially reads all the data that it collected, loads it into memory, and then runs the in-memory forecast model to generate the actual supply chain plan. So in this case, what we did is we put all the MSC tables that are involved in the planning process. So like MSC system items, which stores the master list, the BOM components, the routing operations, et cetera. There's about 10 or 12 such tables that were placed in the memory store. So if you look at, for example, this was a trace of one of the main SQLs that the in-memory planner runs to basically pull all the data that has been collected and then load it into memory and then start the supply chain planning process. So here you can see, for example, like take BOM components, which is highlighted. It took approximately 1.8 seconds, to read a table that has 4 million records, which is pretty impressive. And if you look at the MSC routing operations, that has 16.7 million records, and it took 2 seconds to read that. So normally, again, without in-memory, if this was just doing normal full table scans, even if it's direct path reads or buffer cache reads, these would be in the units of many minutes rather than seconds. So you can see significant improvement. And again, to highlight it, if you're looking at execution plans, that's really what you want to look for. You want to look for those access paths where you see the in-memory access to validate that the objects that you placed in there are in fact utilizing the in-memory store. On Demantra, Demantra is also another kind of add-on to the planning component that some customers use. There are a number of jobs that really improve on the Demantra side. So one is the forecast job itself. And then there's also the background engine jobs that run, which are part of the BLE. And then there's a front-end worksheets. So the front-end worksheets actually are the main usage where the planners are inside. It's called the collaborator. It's a Java application that loads essentially a kind of a worksheet of all the planning items for the items and recommendations that the planners are responsible for. And so the front-end worksheets, I'll explain on the next slide how that works. But typically, if you're familiar with Demantra, most of the worksheet performance actions usually take 1 to 2 minutes, just because of the way the application works. Now, by switching to in-memory, those same operations take seconds. Safety stock and sales history also are another key set of jobs in Demantra that improve significantly. So within Demantra, there's really pretty much 2 key tables that represent the application. One is the sales data, and the sales data essentially stores all the historical sales data as well as the forecast sales data. And in Demantra, you can set it up either weekly buckets or monthly buckets. And then MDP matrix is the one that stores the item and location information. And sales data is essentially the intersection or the cube of that sales data along with the item information. So typically, this is what a worksheet query would look like. And how the Demantra app works is when you log in, it loads the worksheet. And then you select, for example, like a date range that you want to look at, like you want to look at this week's data or this month's data. And then so what Demantra does is it creates temporary tables on the fly. You can see there like the T_date_number. Those numbers are dynamically generated. And so it creates a table. It populates that table with a date range. And then it hits uses that temp table to kind of drive the query, and then it joins to sales data and MDP matrix to basically fetch that data. And there's a lot of aggregation that happens. So without the group by, this would probably produce hundreds of thousands of records, millions of records. But because of the group by, planners, of course, are always interested in aggregation of data. So the query itself produces a couple hundred records. So it's a great candidate for in-memory because it needs to cycle through a huge amount of records, but only produce a small amount of data because of rolled up and because of the filters. So here's an example. Typically, as I mentioned, like when you open the worksheet as a planner, that usually takes 2 to 3 minutes. This case was like close to 3 minutes. And again, the planner has the full view of the data in that view by compared to 4 seconds when the objects were placed in the in-memory store. And if you drill down on a specific item or what's called a cell in the worksheet, that typically would take a minute or so. Now that's down to 2 seconds. So again, significant improvement. So a quick summary. Again, the database in memory, in my opinion, is really a game changer. It's one of the great features of the database because, again, it really allows the application to focus on storing and processing the data, not having to worry about access paths and building out summary tables just to facilitate searches. And it's automatic in the sense that obviously it integrates with the database and the optimizer. And so it just really makes the application access transparent and saves all those headaches of having to build out a reporting instance just for the purpose of achieving good performance. A couple of things just to note is make sure you test thoroughly. Obviously, run through your batch cycles because you will definitely see good improvements on search queries and things like that. But you also want to make sure you run through your batch cycles to see any impact on DML. And then also make sure that you tune the in-memory configuration and make sure you review the set of objects that are being stored there, and then which ones in some cases we did have to create a couple SQL profiles just to force the in-memory access, but in general most of it was automatic. So just some quick references, some links in case you want to make note of those. So a couple of them are the in-memory blogs and links. And then also I just included a few MOS IDs that are relevant with using it with the eBusiness Suite and the mantra as well as the planning. So thank you for your time, and not sure, Ranjan, if we have any time left for Q&A.
So I think the panelists have been answering questions. I don't see anything specific to your presentation as such, but if people have questions related to Ahmad's presentation, please ask in Q&A, and Ahmad will be here and he will answer your questions. So please do so. Yeah. Thank you so much, Ahmad. Very, very insightful presentation. I liked your first line of your summary slide where you said database in memory is a game changer. And also I like what you said about the data growth. I mean, it's not going to stop. It's going to have, it's phenomenal growth happening.
Right. And
whether it's a structured data or unstructured data. And as Tirthankar says, hey, don't die by DIY, okay? Don't do it yourself, okay? And take advantage of the cutting edge solutions that we have, okay? Thank you so much, Ahmad. So
thank you.
Yeah. With that, let me invite next speaker, Thorsten Pensky, to the stage. Thorsten Pensky had been working on Oracle technology since 1993. He's responsible for databases at Lufthansa, and his responsibility includes provisioning, customizing, maintenance, optimizing. He's also responsible for databases related to invoice and human resource planning and so forth. And his title is Oracle in-memory application for reduced latency in maintenance processes. Aircraft maintenance is critical, where a delay in the supply chain can have enormous impact on timetables and customer experience. The overall of an airplane is a complex interaction of many applications and data points. Existing database technologies hit the limits when analyzing such a large amount of data. By introducing Oracle's in-memory technology, operational data is available much faster and reports can be refreshed more frequently than ever before. Thorsten, the stage is all yours. Can you share your slides?
So it should be visible to anyone?
Yes, we can see your slide, yeah.
Okay, great. Thank you, Ranjan. Good afternoon, everybody. As we are at afternoon in Germany here. Thanks to Oracle for inviting me to speak at this summit. In the next minutes, I will tell you a story about how the challenges of industrial business and the technologies of Oracle met and mixed up to a real success. Something that we didn't think was possible until we did it. You will find some parallels to the introduction by Ranjan. It all started about 6 years ago, and I gave this speech at the Oracle Open World in 2017. I refreshed it a bit and added the changes that happened until today. But let me start with the agenda for this presentation. First, I will introduce myself, followed by an introduction of my employee. Then I'll give you an overview of my customers' business in general and of that special segment that forms the basis for our activities. In top 4, I will precise the initial situation and describe the problem we had. Finally, I will show you the use of in-memory, how the use of in-memory helped us and where we are today. Okay, let me introduce myself. My name is Thorsten Pensky. I'm still 51 years old. I made my first steps with Oracle in 1993, and it was Oracle version 6 and SQL Form 3. While studying computer sciences, I worked part-time at an institute that developed warehouse management systems, guidance systems for pallet transporter, and voice-controlled picking systems. At that institute, I had contact with Oracle for the first time, and I was on the development team just using it. Since I changed to Lufthansa, I'm working in a team that's responsible for the administration of the Oracle databases used by our customer here in Hamburg. We're doing all the things that come up when running Oracle databases like provisioning, customizing, maintenance, and optimization. In the meantime, my responsibilities extended a little bit to the organizational part of our team. Some of my hobbies are music, which means listening to it, as well as making it as I play drums in our church band, traveling as soon as it will be reasonably possible again, and scuba diving requiring the previously said. Let's have a look at my employee. I'm working for Lufthansa Industry Solutions, which is a 100% subsidiary of the Lufthansa Group. Formerly known as Lufthansa Systems, we changed the company's name in April 2015. At that time, Lufthansa Systems was split into 3 divisions. The division dealing with infrastructure was sold to IBM, whereas the other 2 remained self-contained. Actually, we have nearly 2,000 employees spread over 10 sites, 9 of those sites within Germany and 1 office in Miami. In fact, a lot of my colleagues are doing their business at the various customers' facilities. Who are these customers? Well, Lufthansa Industry Solutions is acting in several areas. Indeed, our main customer is the Lufthansa Group itself, with a part of about 50% of our turnover. The remaining part is spread among customers from transport and logistics, manufacturing, automotive, energy, media, and healthcare. On the one hand, our service includes counseling concerning strategies, processes, and conception. On the other hand, we provide research in new technologies, development, application management, and services concerning management of databases, B2B, which is especially Web Methods and Service Bus, and SAP. Let's step a little bit deeper into my business segment. Well, here's a picture showing the sites we are based. I'm working in a team of 25 colleagues at Hamburg, 4 of them working in the B2B area. 1 is working on OpenShift in a different department, while the remaining 20 people deal with databases. Beside Oracle databases, we also support Microsoft SQL databases, and about 3 years ago, we set up a cluster for MariaDB. Our scope of services includes installation and maintenance of database software, setting up and administering databases, consulting of developers and customers, tuning of databases and SQL statements, and PL SQL programming. Today, we are responsible for about 270 Oracle databases, 30 Microsoft SQL databases, and 70 MariaDB databases. Their complexity and importance varies from simple databases of some megabyte, which are used only a few times a month, up to databases of several terabyte size being business critical and used on a 24/7 basis. That means we have to provide a standby service for them 25 hours every single day of a year. Now, let's have a look at our customer's business. His primary area of work is the maintenance of aircrafts, and he does this actually at 70 airports worldwide. This includes maintenance, overhaul, and repair of about 4,500 aircrafts of 30 different types. Every single item of an aircraft can be checked, repaired, or exchanged, from a coffee maker via laboratory occupied displays to one of 40 different types of engines or complete landing gears. The second pillar is the support for private VIP, business, and government aircrafts. Besides the complete service portfolio that I mentioned before, our customer fulfills special requests that his customers come up with. This includes cabin assemblies or upgrades that suit the taste of the customer. Moreover, the complete aircraft can be painted to the customer's request. One of the big maintenance events in an aircraft's life is the so-called D-check. This happens to an airplane every 6 to 10 years when it has completed about 30 to 50,000 flying hours. It is a major overhaul where it is nearly completely disassembled down to the skeletal structure. Even the painting may be removed to check for corrosion. Every single part is examined to decide if it needs repair. As an aircraft consists of several million parts, it takes 4 to 6 weeks and 30 to 50,000 person hours to complete the D-check. If parts are found that need overhaul or repair, these are transferred to the customer's own workshops or to subcontractors. The big challenge is to keep track of all the parts that were disassembled, because in the end, they are all needed to put the aircraft together again. So tracking is an extremely important activity in the process. You have to know which components were disassembled and sent for overhaul or repair. You have to know where they are at a given time. Are they in transit, at a workshop, in the warehouse, or already back in the assembly hangar? Are they ready to be used again, or do they have to be replaced? In case of replacement, is the exchange part available and where? You see, tracking is an extensive and important part of the process, and that's where our team comes into play. All the information that are necessary to keep track of the parts are bundled in an Oracle database. We call it the tracking DB. Every activity, every move of a part is reported to the database, including a timestamp stating when it happened. These timestamps are related to different events and form the basis for further reporting. Apart from the information coming from the assembly hangar, there are a lot more sources delivering data to this database. I've outlined the most important ones. On the left side, you see SAP and the data lake. I presume that everyone here knows SAP, so I won't get into detail. Just let me say that the order management, billing, and purchase are processed in SAP. Essentially, the data lake is a mirror of a part of SAP, namely the master data. There is quite a number of databases that need access to data such as material information, for example. To avoid that every database connects to SAP to fetch the same data, we established the data lake. It is refreshed on a regular basis, and every consumer reads its required data via database links. Apart from this, timestamps are delivered from the repair shops and subcontractors, giving information about the progress, whereas the warehouse shows the available stock. All these information are bundled in an upstream staging area. There are 2 tables where the incoming data is collected and divided into keys and values. Downstream processes scan these data and distribute them to different tables. These tables represent the base of the system, the so-called business reports. Every business report represents data according to special demands dependent on the working area they are needed. Above these reports reside the aggregate reports, which mix up data from various business reports. The data for these reports are also stored in tables. Every change in one of the base tables sets an event. This event informs all jobs for the aggregate tables, that have subscribed to these base tables that they need to refresh their data. All these base and aggregate tables have been moved in memory in the meantime. As most of you certainly know, users are seldom satisfied with the views provided. They have their own ideas how data should be combined to fit their needs. That's why at a fairly early point in development, they were given the opportunity to write their own views. And that's when things got worse. One might get the impression that some of them tried to outplay the others in writing the most complex SQL statement. Of course, that was all driven by a professional necessity. But it didn't take very long until the first calls came in complaining that everything is rather slow. Does that ring a bell to anyone? Let me give you some information about the infrastructure we used at that time. We had 4 HP ProLiant servers with an Intel architecture, 12 cores each, and 386 GB of memory. They were connected via 4 gigabit adapters with an HP 3 Parsan that delivered data at a rate of 587 megabytes per second. Of course, these 4 servers are distributed between 2 data centers connected via fiber channel. The operating system was Red Hat Enterprise 6. In 2017, 110 Oracle databases were distributed over the 4 servers. These were 38 production databases and 72 test systems. We used Oracle Enterprise in the versions 11.204 and 12.102. We set up grid infrastructure so we could use ASM, ACFS, and the restart functionality. A high availability is realized by using RAG OneNote, so databases can be moved between the servers without downtime. Additionally, the partitioning option is provided as well as the diagnostic and tuning pack. Later on, the in-memory option came into play. When we take a deeper look into the tracking database as it looked like at that time, we see a version 11.204. Please remember that I'm talking about the situation as it was in 2015. The database's SGA had a size of 24 GB, the PGA had a size of 5 GB. Automatic memory management was activated, and the total size of all tables in the database added up to 1.2 terabyte. Some of the tables are partitioned. On the following slide, you see an example of how a user report looks like. It's the so-called customer status report. It shall give you an impression of how user reports look like. In this case, for every customer, it shows their orders, the parts within the orders and their quantity, the date the order came in, the serial number that was received, the state of the order, and so on. The data shown in this report are retrieved from one of the many views in the database. The view used for the customer status report itself selects the data from 31 tables, 5 further views, and 3 materialized views. Its code had more than 4,000 rows. This makes it quite difficult to do performance tuning manually. But even DBMS SQL Tune surrendered when it found one of the views to select further views, which select further views. That's the point where the standard tuning methods of a normal DBL don't work anymore. We tried everything from creating and dropping indexes of different kinds, moving tables to the key pool, and further partitioning. But with an ever-growing amount of data, all these activities were of short sustained success. The next idea was an upgrade to Oracle 12.1, as we hoped that improvements concerning the optimizer would help us. We migrated the database to version 12.102.2. The results were not as spectacular as expected. So we chose 7 typical and important views to see if we could achieve a significant improvement. One of these reports, the third one in this list, was already performing well and was chosen to see what impact the new version would have on that. You see the runtimes we had in version 11. All the numbers show times in minutes. In some areas, runtimes could be reduced with version 12, but otherwise it got even worse. That's when the idea of the in-memory option came up. We had read a lot about it, and it might help us with our problems. But as the name option says, it's not for free. So we had 2 tasks at hand. First, we had to prove that in-memory would meet the expectations. And secondly, we had to convince the people with the money. At that time, we got in contact with Sonja Meyer of Oracle and planned a proof of concept. She would join us together with Markus Bender for 3 days. Some preparations had to be done before we started with the POC. To be comparable, we had moved all other databases from the one server the tracking database was running on, so we would have as less influence from outside as possible. At the suggestion of Markus, we upgraded the database to the latest patch set. A big challenge was the usage of huge pages on the server. Never did we actually use them, nor had we spent any thought on that subject. So we talked to our colleagues from the Unix department and after some research got them set up. Automatic memory management and the usage of huge pages doesn't match, so we had to switch AMM off. As we had to think of accurate values for the memory parameters anyway, this was no problem. A more sophisticated task was to decide which tables we would move to in-memory at first. We might have used the in-memory advisor, but as we already had chosen the views we would like to investigate, we went for a manual choice. So we looked at the views in all their complexity, identified the necessary tables, and moved them in memory. And here's an excerpt of the tables as they reside in memory. In total, we moved 76 tables to in-memory, and we got a first look at the compression as an integral part of in-memory. We had moved them with mem compression for query high, which means that compression is used, but our focus is primarily on query optimization. The data you see here is retrieved from the view $im segment and shows that although we told memory we have a need for speed, compression isn't already completely put aside. The factors vary from 102, which is not on this excerpt, to 33.84, which is a real exception but highly welcome. The average overall, the 76 tables, is a factor of 3.63, which means you need less than half of the original size overall. In our case, 53 GB of memory were used compared to 110 GB of data in the tables. But when we put the whole output of the view under the microscope, we found two curiosities. First, we found 2 tables needing more space in memory than on disk. Thinking of problems during the transfer to in-memory, we removed them and started over again, but the result didn't change. We were quite confused. Then I got the opportunity to talk to Tirthankar Lahiri, and he explained to me that in-memory itself needs a little bit of memory. So with small tables, this behavior can be expected. That's no problem, but you have to be aware of that. The second case were 2 tables of significant size that showed the same effect. Their size in in-memory was larger than the original size on disk 2. Reloading these tables didn't change the behavior as well. Nevertheless, we decided to leave them in memory. Unfortunately, we lost track of this issue as our main interest was if in-memory would speed up our statements. So we cannot really say at which point this issue vanished. We installed 2 more bundle patches in the meantime, and maybe one of them fixed that misbehavior because at any time these 2 tables were compressed as well. It didn't occur again until today, so we filed it away. Then came the moment of truth. So we refilled our mugs, took a deep breath, and started the first attempt. We started without any changes like parallelism or dropping indexes. The first results were like winning the jackpot. All but one view finished much faster than before, and we had done nothing but moving the tables to in-memory. And even those 2 reports whose execution we had to stop in version 12 because the response time was endless, returned within very reasonable times. The response time of one view was extended by 50%, but as we had just begun, we didn't worry about that. In the next step, we set all the indexes to invisible so that the optimizer wouldn't use them. To keep the prerequisites as equal as possible, we bounced the database after every test case. So most of the results were similar to the first, sometimes better, sometimes worse. Only the one view whose runtime grew within memory now even didn't come to an end. After some research, we found the reason. I'll come to this with the next slide. The next two tests involved parallelism. We set the degree of parallelism to 4 and tested the response time of the views again, one time with indexes, the other without. Again, we got some interesting results. In 2 cases, we got the best results we would get in all our tests. You see them in the bold figures. But in some cases, it got worse. You see the report that until now was very inconspicuous even without in-memory. Its runtime increased approximately by factor 16 to 18. And again, we had the same problem with one report not returning from its selecting travel. And this is why. Looking at the execution plan, you see a vast usage of temporary table space when dealing with a hash group by. Although only 69K were requested, the optimizer was misdirected and assumed a total of 16 GB to handle with. This was finally found to be a bug and was fixed by a later bundle patch. So no worry about that any further. In the next turn, we went one step further and set the parallel degree policy to auto so that Oracle would decide how many parallel threads to use for the best result. To the surprise of all, Oracle only used 2 different ways. Either it chose a parallel degree of 8 or it ignored parallelism completely. I put it in parentheses to show Oracle's decision. In one case, we got an extraordinary result that I also marked with bold figures. Do you remember the situation we had with Oracle 11? The performance report took 10 minutes to finish, and now it returned after just 1 second. It was so unbelievable that we repeated the test to reassure that finding, and it really did. That was really exceptional, but as you can see at the other times, not the rule. One further test was done by computing new statistics for the tables to see if that would have any impact. And in some cases it did. You can see that some response times were reduced further. So what results did we achieve? For a proper evaluation, you have to compare them with the runtimes of the version 11G because that's where we were coming from. Apart from the run report that suffered from the bug concerning the temporary table space, every runtime was cut by factors. From a small factor of 1.5 up to the incredible factor of 600. These results impressed our customer, so he agreed to invest into the memory license for the cluster. As you remember, we use a shared infrastructure. That means we're running several databases on each server, sometimes competing for the resources. So we have to keep an eye on every database and cannot let them operate to their own discretion. That's why we started without parallelism. In this way, we started without the big factors, but the results were still really good. When we had a further look at the $IM segments afterwards, we found an interesting curiosity. Although the view told us that the population of all tables had completed, there were still bytes supposed to be populated. Some investigation showed that the status of the view partially was wrong. As we moved more tables to in-memory, we reached the limit we had set for the in-memory area. Therefore, the status column was definitely wrong. It became apparent that we found another bug that was fixed with the next patch. One can get the impression that there are a lot of bugs with in-memory, but at that time, the technology was just released. It was a rather new technology, and all the bugs we found didn't have impact on the core functionality. Apart from that, Oracle was very quick at fixing the problems. Over the years, we hadn't had any failures concerning in-memory anymore. What did we learn? Well, in fact, the technology of in-memory solved our problems and still does today. And it did it in a way we never thought possible. No search for helping indexes, no query rewrite, just simply by moving the tables to in-memory. As I said before, we started without parallelism due to our shared infrastructure. But until today, we don't miss it. Runtimes have been cut by an average of 30%, and the reduction of disk I/O is an additional benefit to our infrastructure, and the database is running beside this one. We could reclaim some disk space too, as we dropped several indexes. That's a nice side effect, but wasn't our primary aim. With the implementation of in-memory, we even allowed our customer to use dynamic SQL to write queries that meet his own requirements. What changed until today? Well, a lot. We replaced all 4 servers of our cluster by ones that are more powerful and with a lot more memory. A new SAN storage system was established, which allows faster access. And finally, the databases have been upgraded to version 19.10. Concerning the tracking DB, we moved all tables to in-memory by the time. That means we actually keep more than 200 tables in memory. According to a growing number of tables and data today, we now have an in-memory area of 240 gigabytes in that database. Many more views have been created, and their complexity is far behind the status of 2015. The possibility to use dynamic SQL has become an essential part in daily work. Apart from the tracking database, we have implemented in-memory on a different one suffering from massive disk I/O generated by the access to one table. We activated in-memory, moved the table to in-memory, and were able to reduce the disk I/O of the database by 90%. And we did that just within 1 hour. Actually, we are implementing in-memory on a material supply database, but have been thwarted by COVID-19. But I think that topic will be on the agenda again soon. Let me come to the end of my speech by giving some hints. As I said before, we didn't use the IM advisor. It's not because we don't like this tool. It's great if you are to launch the technology or have no knowledge about the application. But experience has taught me that knowing the application and its purpose, you can achieve an even better performance by choosing the tables by yourself. If you can have influence on the development, that's perfect. Recently, the information reached me that with Oracle 19.8, a so-called base level was released. Tirthankar showed it in his presentation yesterday too. Base level means that you can use the in-memory functionality for free within some boundaries. The size of the in-memory area can't be larger than 16 gigabytes, for example. But hey, keeping the compression in mind, that's worth a second thought, especially as you may use it even in production. We are running a second cluster that is identical to the one we have been talking about today, apart from the in-memory option. But with the base level, we may use the in-memory option on that cluster too, and eventually don't need to move the database to the in-memory licensed cluster. Finally, one small drop of bitterness. Primarily, the tables we move to in-memory are used within select statements. Nevertheless, there is a lot of OLTP hitting the database. We're talking about up to 250,000 timestamps per day reaching the database. The population of these changes to data is done quick and never formed an obstacle. But as time goes by, it seems that DML leads to some kind of fragmentation within the in-memory area. Even if the total amount of data doesn't increase, you see a decrease in free memory. And that happens apart from the change in size caused by DML Andy talked about yesterday. Until today, the only way to solve this is to remove the tables from in-memory and reload them again. This can be done online, no problem. Actually, we do this automatically once a month, even if it wouldn't be necessary yet at the time. I must admit that I haven't checked this behavior on the latest version of 19.10, as we upgraded the database just recently. Maybe there have been some improvements made on this point. We'll see. Well, that was a short overview of how and why we got started with the memory. If you have any questions, we may have some time now. Otherwise, feel free to write me a mail. I'll put it to the Q&A too.
Yes.
Thanks for your attention.
Yeah, thank you, Mr. Pensky. So actually, there are a few questions. If we can quickly answer live, that will be great. Otherwise, maybe we can deal with them offline. So the first question is, what is the best approach in choosing the tables to be cached in IM, and what factors influence this decision?
As I said, there are 2 ways to decide which tables to choose. Either you use the IM advisor, which is a great tool, especially if you are new to this technology or have no knowledge about the application you want to use in-memory for. In our case, we knew the application, we had insight to the views we could see which tables were used and how, and that's why we choose the tables manually. You can do it either way.
Okay, that's great. Yeah, thank you. The next question is, how much physical memory did you add to the SGA during your tests?
We came from an original of 24 gigabyte, and and by today we have added 16 more gigabyte. That means we have a total SGA of 280 gigabyte, of which 240 are used for a memory and just 40 gigabyte used for the SGA itself.
Okay. Okay, thank you. And there's one more question. What to do if the tables are highly normalized?
I think that's no problem for in memory. We have several databases that are normalized too, and it doesn't set up an obstacle for in memory.
Okay, sure. Yeah, thank you so much for your presentation. If there are other questions, attendees, please feel free to ask question in the chat window. With that, Mr. Pensky, you can unshare your slides and we can let Benoit share his slide. Okay, so our next speaker is Benoit Colas. He is a BI and EPM manager at Steph. Over the last 22 years, he has been working for two major French companies, Dassault Systems, where he worked as developer and manager of ERP implementation, then Steph, where he's in charge of building a performant BI and EPM environment for business users in Western Europe. The title of his speech is In-Memory Data Warehousing at Steph. Steph is the European leader for temperature-sensitive logistics. A business intelligence information system is key in Steph day-to-day activities monitoring. Using Oracle database in memory, overall reporting and analysis from transport services orders to billing information is now delivered to business users on a daily basis. It allows business users full self-service on very large amount of data, enabling fast decision and in-depth analysis on large data sets. Benoit, you have the stage. Please go ahead.
Thank you, Rajan. As you said, I'm a software engineer, so absolutely not a database administrator. I'm only a database user. And my presentation is about how we use in-memory technology for data warehouse and for BI. Here is the agenda we will go through. Steph is a €3 billion turnover company, a European leader in temperature control, logistic and transport services. And every day, the 19,000 employees work to provide our customer logistics solutions that comply with food security and lead times. Our customers are agri-food manufacturers, retailer, seafood industry, and out-of-home food service businesses like restaurant or wholesalers. Steph operation goes from production, collecting goods from industry and producer to our warehouse, where we can provide added value services such as storage, of course, but also order preparation, packaging, co-packing. We can also provide our customer supply chain optimization, control tower, and IT and digital solution. And we go to the transport to the distribution place, such as supermarket, wholesaler, restaurants. To help understand what Steph business is, we used to say that in a Western European country, everything you have in your fridge or freezer goes through Steph operation. Steph operates in 7 European countries: France, Italy, Spain, Portugal, Belgium, Netherlands, and Switzerland. We have more than 250 platforms and warehouses and over 4,000 vehicles to achieve our goals. And Steph also export and import from 15 European countries. So on all this platform and site, business manager need detailed and daily information to manage their activities. It goes from field sales to operation to operational controlling, human resources, purchase, and the BI team mission is to give all this manager the right information to support decision process and analyze in detail their activity. 10 years ago, we changed the BI team mission from producing reports for the business to deliver a centralized BI full self-service. In terms of database usage, delivering reports can be made by studying the query run by the report, added indexes when performance are not what we expect, even using hints for the query run against the database. When you provide a BI full self-service to your user, you do not know what queries they will make. So you change drastically how you design your database schema. And what we try to do is to limit aggregation against data to avoid losing information and to limit business rules that we apply on data. And we try to provide what I call a raw data model as a star schema with fact tables and dimension. Before using EMDB, our business intelligent information system was able to achieve this goal on low data volume area. When I mean low data, it's up to several million of facts a year. So of course for sales opportunity, customer service call, but also for employee time tracking or warehouse management, stock management and order management. But we were not able to achieve this on the transport management activity, which is the core business of Steph Group. And for this area, analyzing the transport, we were able to provide our user data mart updated once a week. We built a centralized information system for the last 20 years, and BI environment is built the same way. We have only one database that collect data from all the different applications used and deployed in the group. For example, SAP for finance, human resources, purchase to pay process and plant maintenance. All this data coming from SAP is collected and stored in the data warehouse database. It's also the case for the sales part coming from Salesforce with 2 modules that we use, sales management, and customer services. So SAP, Salesforce are traditional application deployed in company, and we have a specific application linked to our business, time tracking application, and home build solution for warehousing management system and transport management system. The data volume of our data warehouse is 20 terabytes. Just to give you a global overview of our BI information system, we process all the data through a single ETL tool, which is the tool from Pantao Data Integration. And the production of the 200 ETL process is streamlined through one automation to manage our production. And data stored in our data warehouse is delivered to our users through three main solutions: IBM Cognos Analytics for reporting and self-services, Pantao Business Analytics for dashboarding, and Oracle Hyperion Planning for forecasting and budgeting. What was our journey of adopting a database in memory? We started in 2017 with a proof of concept. At that time, we decided to change our server, and we take the opportunity to study IMDb to work on performance we can deliver to our customer. Our proof of concept server was up to 700 gigabyte memory, and the version used was 12C. As our test was successful, we decided to invest in a production-like server with 3 terabytes of memory, and we try to take the existing data warehouse and upload all the tables in memory. But this was a failure. We did not have enough memory space to do this. So we spent the next part of 2018 refining our usage strategy. And we decided to split or partition our large table in two, with one partition we call warm for recent data, which is loaded in memory, and one partition which we call cold for older data, and that will remain on disk. We also review our indexing strategy, because when you want to deliver full self-service to your user without in-memory, you need to create a lot of indexes, and especially in BI, bitmap indexes. And before adopting in-memory, the size of indexes was the same as the size of data in our Oracle database. We going to in-memory, we suppress all the bitmap indexes, and we only kept indexes with large cardinality, so near a primary key for each table. And in September 2018, we migrate to version 18C. Our go live of in-memory in production was done in April 2019. and the version used for deployment was 18.11. So at that time, we took the schema, the star schema we have, and we put it in memory with the refining I just mentioned. And in March 2020, during lockdown, we launched a large project on the transport analysis, activity analysis, the part that I mentioned before, we cannot deliver data daily. And in 6 months, we go live with a new data mart that I will explain in the next slide, which is the largest creation we did on in-memory today. But before that, in last April, we upgraded in 19C, and now our production is 1910. And there is important fixes that improve query performance in this last version. So let's focus on this data mart we just created the last year. Our goal was to give our business user a daily updated data mart on transport activity, from transport order to billing and after delivery services. So it goes through customer order, all the monitoring of unit load at each step of the transportation, with all the associated resource taking in charge the unit loads, human resources, of course, staff human resources, but also subcontractors and all the vehicle in which we load and unload, or from which we unload the products. When when staff end with dealing with the customer product, there is of course invoicing, external and internal invoicing, internal between the different sites, credit notes and dispute management, and all this information is placed in one data mart to enable our business to analyze this activity. This result in 2 billion line fact table with 212 columns and 64 dimensions, and it represents more than 1 trillion, so thousands of billion information available to our business user. These data are daily updated, and data up to 7 a.m. are available in BI at 9 a.m. every morning. On the right, I added a graph where you can see how many operation we do for this data mart only on the database. Each day we are doing more than 100 million update, 10 million insert and delete on this only fact table. I wrote white paper like document I call how staff implements Ralph Kimball's best practices in Oracle in-memory database. If you are interested in, just ask me, I can share that with you. The idea was to document how we model our star schema and how we use in-memory in this type of usage. So what are the impact of using EMDB? For my opinion, or in my opinion, for business user, in-memory is even. Overnight, the performance of their query are divided by 10 up to 100. They have access to any information in seconds, even on a large period of time. Over a 2 billion line fact table, analysis takes seconds to few minutes. And it's really, as the previous speaker said, it's a game changer. For data engineer, in memory is opening new perspective. Data volume and processing issue are postponed to the next level, but it's very important to work on the data model, and in memory is doing the rest. And for database administrator, in memory is a skill upgrade. Usage of indexes have to be reviewed and have to be reduced to the minimum. To give you an idea of our server, we have so just one server, 4 CPU, 8 cores, and 4 terabytes of memory. Our business continuity plan and disaster recovery plan are managed by DataGuard, and so all the transactions are replicated on a backup server to be able to recover from any problem on the first site. Some key number about our database. We have 19 terabytes of data today. Today we have 19 terabytes of data, 6 terabytes of indexes, and 9.8 terabytes of data are uploaded in memory, which took 2 terabytes of space in memory. Our database starting time is 9 hours. So I put a screenshot of the DBA command to see the size of our different in-memory area. What are the next steps? We want to continue developing new data mart on strategic area of our group for Steph. So all the doc activity data in the perspective of optimizing all the operation on data on a warehouse. Sorry, we are currently redesigning our billing part of our 360 customer data mart to give a billing section detail as it is in our transport data mart. We want to explore the usage of in-memory for advanced analytics purposes, such as activity forecasting or predictive maintenance. And also, we plan to collect IoT data to be able to expose and analyze the data coming from sensors to our business analyst. So for me, adopting in-memory technology is a one-way trip. For a business user, it saves time, it increases analysis capability. For data engineer, it breaks down some barrier related to data volume and time processing, but I think it's not magic. For BI, data modeling is the key. Load all your data in memory will not solve all your performance problem. As you listen to the different speaker, it helps solve a lot of performance problem, but not all on in my mind. And for database administrator, it's really not a big deal, just a skill upgrade. So before ending my presentation, just want to thank you Oracle team, ACS with Christophe, and the product team that help us in our project. And I want to thank you, the staff teams, my team, of course, but also the DBA teams, Hubert and Eric, that works hard to make it work at staff.
Yeah, thank you so much, Benoit. Such a great presentation covering all the implementation details, motivations, learning, everything. Thank you so much. There are a couple of questions for you, Benoit. So one is a quick question for Steph presentation. Are you not using rack, and the backend storage is SSD or disk for 9-hour startup?
So we are not using a rack. And on the storage, I'm sorry, I cannot answer the question as I'm not.
I think the question is, are you is the backend storage SSD or disk for 9-hour startup?
I don't know if it is
okay.
SSD.
Sure. Okay. So there is another question, which is, which kind of IAM compression is adopted in your data warehouse?
I think it's a query law.
Query law. Okay. Great. And then do all the tables have the same query law?
Yeah, we use the same parameter for all the tables.
Okay.
And we did not try to change it. It could be a way to improve, but we just use one type of compression.
Okay, got it. Okay. I don't see any other specific question for you. So attendees, do you have any other question for Benoit? Okay, so attendees are trying to thank you. So thank you so much, Benoit, for your presentation and time. So I mean, one thing I commonly heard across the 3 presentations was all of you said that the database in memory is a game changer. And definitely, I mean, that resonates with us as well. So thank you so much for all the presenters for your time, and also all the account teams and all supporting you. It's always a teamwork. So anyone has any of the speakers, Ahmad, Mr. Pensky, Benoit, any last message for the audience?
No.
Okay, so I think we are doing great on time. Anybody else has any comments? Shashank, Shalendra, Andy, any comments?
No, just thank you very much for those presentations. It was our pleasure to work with you guys on this. If anybody has any questions, as Ranjan mentioned, please don't hesitate to reach out to us. Email, any which way you can, and we'll be happy to help you.
Yes, definitely. Go ahead.
So, Ranjan, I just wanted to add a few things. I think obviously, I would like to thank the presenters, and it was an excellent presentation. But I would also like to thank the participants who asked some very, very good questions. And then I think we have got a very nice database of questions. I think one of the things that we sort of promised that we would not only share the presentations, but also the questions and answers, and that we will. Plus, from time to time in my answers, I have shared the emails of people that you can get in touch with. Feel free to ask us for anything at all, and we are here to help. Make sure that, if you, the fact that, I mean, like Ranjan said, that the thing that basically, everybody said is that in-memory is a game changer, and we want you to use that game changer. And we are here every step of the way to basically help you do that. So thank you very much.
Yes, exactly. Yeah. So just want to also kind of remind everyone that we have another presentation, great presentation coming up and this is the presentation by Hisense. That's in the evening, our PST time, but please do call in for that presentation as well. Again, all these customer presentations have a lot of insights, learning, best practices from the real life implementations, right? So all those customer presentations are great. Thank you all attendees. We will stick by here. If you have any question, yeah, or feel free to drop. But again, there is another presentation coming up later in the evening. Please do join there. Feel free to ask questions. We'll be here until at least 10 o'clock our time. So. Ahmad, since you're here, is there anything you want to talk about? There are still few attendees lingering here. So you want to talk about the CyberNor or any of your contact info? I still wanted to provide detailed info to the attendees.
Yeah, sure. You can share my contact info, and I'll also include it in the deck that I'll send you.
Okay. Yeah. So. Yeah. So Ahmad has a lot of expertise in system performance and other things, and he has worked with a lot of Fortune 500 companies and small, medium-sized companies as well. So yeah, feel free to reach out to him. I did provide the email ID in the chat window, so hopefully people got that. Looks to me, are there any open questions?
There is one open question with regard to Steph. I mean, so the question is, Steph is having 19 terabytes of database. How much SGA and in-memory was being used?
Okay, so Benoit, if you're still around, this question is, if you can answer the question.
I didn't hear the question.
Okay, I can repeat the question. So Steph is having 19 terabyte of database. How much of SGA and in-memory was used? Do you remember that by any chance?
No, but I can try to ask a question, because as I'm not the DBA, so
sure.
but I can ask for this.
Yeah, maybe you can just yeah, no, that's fine. I mean, if there's any high level answer or something, that's fine, but otherwise, yeah, I mean, it's too hard to remember some of this data. Especially if you're not a DBA. So
yeah.
You did mention though that it was compressed to, was it 6 terabytes, I think is what you said? So it was at least that much, 6 terabytes. I think it was 6 terabytes is what you mentioned.
That's the in-memory size, right?
Right. So I'm just saying that's how much, at least 6 terabytes was used, let me put it that way, for memory.
The person who's asking is Mirza Abdul Namir Beg, and he wants the SGA size as well. So anyway, I mean, his email is there in the question. So, you know, if we can find the answer, we'd love to help him.
Yeah, yeah. So I noted his email ID and we can follow up.
Okay. Ranjan, maybe I can give an approach to the answer. From what I can remember from a customer Steph configuration, the SGA is shot to 4 terabytes and the in-memory size is shot to 3 terabytes.
Okay,
Hope
awesome. Yeah,
it's give a better picture of
yeah,
configuration.
yeah. That's great. How do you remember, Christoph? Yeah, no, thank you so much.
Christoph has been working on this for a long time now.
Yeah.
Okay, all right. Looks like no other question, right? So I think maybe we can end the meeting now. Again, thank you everyone for joining. And we do have another session. Please do join for that session also. Yeah, we look forward to working with you, collaborating with you, or helping you as much as we can. Okay, so yeah, let us know in any ways we can help. Thank you so much. So with that, I'm gonna end the meeting now. Thank you all. Thank you all the presenters, supporters, account team, everyone. Thank you so much.
Thank you.
Thank you.